The paper explores the broader utilization of data augmentation methods based on masked language models, MLM, in natural language processing. It begins by discussing the prominence of pre-trained language models such as BERT, RoBERTa, XLNet, T5, and BART, which have revolutionized the field of NLP. These models rely on transformer-based architectures and unsupervised learning, trained on large text corpora to learn useful representations of language. They can then be fine-tuned on specific tasks with smaller amounts of task-specific data. The paper highlights the importance of high-quality annotated data for NLP tasks, which can be expensive and difficult to obtain. It also discusses how researchers have started exploring cheaper annotating methods, such as those based on distant supervision. The authors introduce the concept of masked language modeling, a key feature of BERT and similar models, where some percentage of the input data is masked during training, and the model is trained to predict these masked words based on the context provided by the unmasked words. This approach enables the model to learn a deep, bidirectional representation of the sentence, leading to significant improvements on a wide range of NLP tasks. The paper then delves into the details of each pre-trained language model, including their unique features and contributions. For instance, RoBERTa extends the training time, uses larger mini-batches and learning rates, and removes the next sentence prediction objective that BERT had, leading to improved performance. XLNet combines the advantages of BERT with autoregressive language models, introducing a permutation-based training objective that allows it to learn the dependency of words on both their preceding and succeeding context. T5, on the other hand, treats every NLP problem as a text generation task, simplifying the application of the model to a wide variety of tasks. BART combines the best of both worlds, combining bidirectional context learning from BERT and the sequence-to-sequence nature of models like GPT, achieving state-of-the-art results on various benchmark datasets. The paper also discusses the limitations, assumptions, and future work discussed in the field, emphasizing the need for further research on how to effectively utilize these data augmentation methods based on MLM. It concludes by highlighting the potential of these models to revolutionize the field of NLP and improve model performance in various tasks. Investigating masking-based data generation in language models, we explore the role of masked language modeling in pre-trained language models. By learning to predict missing words in a sentence, models gain a deeper understanding of language context and semantics, leading to significant performance improvements across various NLP tasks. Data augmentation is another crucial technique, enhancing the quantity and quality of training data. We discuss various methods, including paraphrasing, noising, and sampling, which ensure the generated data is valid and diverse. The success of pre-trained language models in recent years has also led to their utilization in generating augmented data. Techniques like masked language models, GPT-2, and BERT are employed to create both corruption and reconstruction models, resulting in high-quality augmented data. Unsupervised methods, such as mix-up, leverage in-labeled data to generate additional training examples without requiring explicit annotations. Lastly, machine translation, particularly back translation, is explored as a method for data augmentation, offering a natural way to paraphrase text. These techniques collectively demonstrate the power of data augmentation in enhancing the performance and robustness of language models. The paper discusses the role of data augmentation in enhancing the performance of pre-trained language models, particularly focusing on masking-based data generation. It highlights how masking-based data augmentation can be applied to various pre-trained language models, including those that go beyond the traditional masked language modeling, such as T5 and GPT. These models have demonstrated superior performance in capturing linguistic properties, semantic relationships, and contextual nuances. The authors emphasize the importance of leveraging large language models like GPT-3 family models for scaling instruction fine-tuned language models. They also explore the use of unsupervised data augmentation methods for semi-supervised named entity recognition and natural language understanding tasks. Furthermore, they discuss the integration of pre-trained models for generating high-quality synthetic examples using techniques such as conditional generation or controlled generation. The paper also delves into the realm of emerging data augmentation techniques, including those that utilize adversarial training to enhance model robustness and performance. It mentions how these methods can expose models to challenging and diverse examples, mimicking real-world linguistic variations and potential attacks. Additionally, it highlights the potential of using large language models for data enrichment by leveraging their embeddings or contextual features to develop new data enhancement strategies. Moreover, the paper discusses the effectiveness of masking-based data augmentation in improving the performance of pre-trained language models. It references several studies that have utilized this technique to achieve state-of-the-art results in various NLP tasks. The authors also emphasize the importance of incorporating these augmented data into the training process to enhance model performance on downstream tasks. Finally, the paper concludes by discussing the limitations and future work in the field of data augmentation. It acknowledges the challenges posed by large language models, such as scalability and computational demands, and suggests potential avenues for future research, including exploring new augmentation techniques and integrating advanced models for data generation and enrichment. This section of the research paper delves into the realm of data augmentation techniques in natural language processing, focusing on the role of pre-trained transformer models in enhancing various NLP tasks. It begins by discussing the concept of masking-based data generation, which leverages BERT for robustness in text classification and entailment tasks. The paper then explores different approaches to data augmentation, including the use of pre-trained language models, sentence editing, and mix-up techniques. The authors also delve into the application of data augmentation in real-world scenarios, such as detecting phishing emails and improving breakdown identification in dialogues. They discuss the limitations and challenges of current data augmentation methods, emphasizing the need for more effective and efficient techniques. Furthermore, the paper highlights the importance of semi-supervised learning and cross-attention supervised data augmentation for question-answering tasks. In addition, the authors touch upon the concept of TextBugger, a tool designed to generate adversarial text against real-world applications. They also mention SSMBA, a self-supervised manifold-based data augmentation method that improves domain adaptation for dialogue act tagging. The paper concludes by discussing the role of neural retrieval for question answering, utilizing cross-attention supervised data augmentation, and the use of BERT for improving out-of-domain robustness in dialogue act tagging.